Hi everyone! Today we're going to go over lesson 4-1, which is graphing quadratic functions. So for our first example, we're going to graph f of x equals x squared plus 3x minus 1 by making a table of values. So we're going to choose values for x and evaluate the function for each value and then graph the coordinate points. So in this case, we're going to use x from -3 to 1. To get our y values, we're going to substitute the values for x in, and then simplify. So for example, for -3, our equation is f of x equals x squared plus 3x minus 1. We plug in -3, so -3 squared plus 3 times -3 minus 1 gets us -1. So our coordinate point is -3, -1. And then we do the same thing for -2, -1, 0, and 1, and we get our coordinate points. Looking at the graph, you should notice that we do get a symmetry of our values in the y's, which would make sense because it is a U shape. So then we would plot this, and we do remember we are doing a quadratic, so it does make sense that we would have repeating y values. So go ahead and give this graph 2x squared plus 3x plus 2, and then pick the graph that matches. Okay, so by doing this, we do know a couple of things actually just by looking at our equation. The 2x squared plus 3x plus 2, we should know that it opens upward, and with that, we can at least cross out a and d. But I can go ahead and choose a value that we do know that they picked for us. So if I plug in 0, we should get 2. So my answer is C. So for the graph of a quadratic function, which is also known as a parabola, we can find some information that's very important for us. And this is always for y equals ax squared plus bx plus c, where a does not equal 0. Your y-intercept is always going to be the c value. The equation for the axis of symmetry is x equals -b over 2a. -b over 2a is also the x-coordinate point of the vertex. So axis of symmetry is exactly what it sounds like. It's where the point of symmetry starts. If we were fold to along that line, they would match up perfectly, and we wouldn't be actually able to tell the difference. And with that, we can usually tell a couple things. So the distance that the y-intercept c is going to be the same distance at that same height, but in the opposite direction from the axis of symmetry, which you can use to go ahead and plot your coordinate points when you're given limited information. So for example 2, consider the quadratic function f of x equals 2 minus 4x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So we're going to rearrange these so that this is in standard form so that we can identify our a, b, and c values. So standard form here would be 1x squared minus 4x plus 2. The reason we're going ahead and adding that 1 in there is so that we can identify our a value. So a is 1, b is 4, c is 2. B is -4. So because we know our c value, we can determine that our y-intercept is 2. And by using a and b, we can find the axis of symmetry. So we're going to substitute -4 and 1 in to get x equals 2. X equals 2 is also the x value of the vertex. All right, example 2b, consider the quadratic function f of x equals 2 minus 4x plus x squared. Make a table of values that includes the vertex. So this is using information from the previous example. So we need to remember that our vertex x value is 2, so we need to choose values surrounding that. So we usually would start by putting the vertex in the middle and then counting up and down in the directions. So we're going to use 0, 1, 2, 3, and 4. with 2, -2 being our vertex. Next, we're going to consider this information to help us graph. So you would start by graphing the x and y, the y-intercept and the vertex, but then you also happen to actually know your reflection of the y-intercept. So since it is symmetrical, so we can go ahead and graph that. And since we know we also made those coordinate points, we can graph our information. So considering the quadratic function f of x equals 3 minus 6x plus x squared, find the y-intercept, the equation of axis of symmetry, and the x-coordinate of the vertex. All right, so looking at this, we would need to go ahead and rewrite this. So when we rewrite this, we would get x squared x squared minus 6x plus 3. So we have a equals 1, b equals -6, and c equals 3. So I know my y-intercept is 3. With that, we cross out b, and we also cross out d. My axis of symmetry is -b over 2a equals x. So -6 over 2 times 1 gets us -3. 2 negatives make a positive, so x equals +3. So our answer is C. So now we have consider the function and make a table of values. Well, we know the vertex, we know our y-intercept is at 3. So basically, actually, by knowing that at 0, 3 is a coordinate point, because that is my y-intercept, I need to really only look at the first term on all of these. And with that, I can actually already tell you that the answer is D. You're also welcome to go ahead and graph the function in Desmos and turn it into a table to get a list of values. So based on the previous information, we need to go ahead and graph. So part of this, we do know 0 equals 3. 0, 3 is our y-intercept. With that, our answer we know is A. You could also use the table off the previous graph to go off the previous question to plot the points as well to get your graph. Minimum and maximum values in a quadratic pretty much just means what is the highest point and what is the lowest point. If your a value is negative, you will have a maximum. So this would be a negative a value. If it opens up, we have a positive a value, which means you would have a minimum. Your minimum and maximum is the y-coordinate of the vertex. So we could actually, that's easy to find, even if it's in standard form, by using the axis of symmetry equation, -b over 2a, to determine the x value that you would need to plug in to find your min or max. So considering the function f of x equals -x squared plus 2x plus 3, determine whether the function has a minimum value, min or max. So we're literally going to look at our a value, and since it says -x squared, we know it's negative. Because it's negative, we know it opens downward and looks like this, so we have a high point, which is a max. So this time we have consider the function and tell us what is the min or max value. So we're going to use the x-coordinate of the vertex by using negative b over 2a, which simplifies in this case to 1. We would then plug 1 into our equation and find that we get 4, so the maximum value is 4. Next, we're going to go ahead and state our domain and range. All quadratics have the same domain of all real numbers, unless we are putting limitations on a real world example or some other reason for that, or like a word problem. But in generally speaking, unless we are actually applying the quadratic function to an example, the domain is going to be all real numbers. The range is all real numbers less than or equal to the maximum value. So this is true when the graph opens downward. We would have a high point and then it goes down to infinity. If it opened upward, we have a low point and goes to positive infinity. So these are two ways you can see it. You can also see them using the embolded R for the domain. And you might also see this using the interval notation from negative infinity to positive 4. Positive 4 would get a bracket, and negative infinity, as always, would get a parenthesis. All right, consider the function f of x equals x squared plus 4x minus 1 and determine whether it has a min or max. All right, so looking here at our a value, we see that it is a positive a value. So that means it opens upward, and so we would have a minimum. So our answer is B, minimum. Considering the same function, go ahead and tell us what the maximum or minimum value is. All right, so we're going to use that x equals negative b over 2a. We know b here is 4, so we're going to get negative 4 over 2 times 1, which is our a value. So it's negative 4 over 2, which is just negative 2. I then take this value and we're going to substitute that in. So we're going to get negative 2 squared plus 4 times negative 2 minus 1. So with that, we have negative 2 squared is positive 4. 4 times negative 2 is negative 8 minus 1. So negative 4 minus 1 is negative 5. So our answer is A. Now we're going to head and determine the domain and range. All right, so as we said earlier, all quadratics have the same domain of all real numbers. And with that, we're going to cross out C and D. And then we found that we have a min. So that means negative 5 is the lowest number. So we're looking for the inequality facing away from negative 5, which would be A. So next we have a real world example. A souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for each 50 cents increase in the price, he will sell about 10 fewer coffee mugs per month. How much should the owner charge for each mug in order to maximize the monthly income from their sales? So we want to know basically income equals number of mugs times price. So we're going to let x equal the number of 50% price increases, and I of x will be the total income of a function of x. So the income is equal to, so that's how we get I of x equals 200 minus 10x, so the number of mugs, times the price per mug, 6 times 0.5x. So here is our function. We're going to go ahead and distribute this. We're going to multiply the first term 200 times 6 and then 200 times 0.5x. then negative 10x times 6 times negative 10 and negative 10x times 0.5x. And then we will simplify to get 1200 plus 40x minus 5x squared. They're going to go ahead and rewrite this in standard form. So negative 5x squared plus 40x plus 1200. So we're going to find the max, we're going to go ahead and find the x coordinate point of the vertex, which we find to be 4. We're then going to plug 4 into our equation. So to get the most money with the most sales, it would be selling them for $8. Using the same information, we're going to find what the maximum monthly income for the owner can expect to make from these sales. So to determine the maximum income, find the maximum value of the function by evaluating I of 4. So we're going to plug in 4, and we find that the answer is $12.80. So using the same steps from the previous example, we're going to go ahead and go with this, using the same steps. So the setup, going back to that, we would go and double check and make sure we have it, is we're going to go with, you want to copy this setup here. So we're going to have the number of mugs times the price per mug. So the number of mugs minus 10x times the price this would be our setup, and we would go ahead and solve the same way and get that the answer is C, $17.50 is how much they should charge. Using that equation, you would plug $17.50 in, and you would get that the amount is $6,125. That is the end of our lesson, and I'll see you next time.